we're given the location of the foci, negative 4, 0, and 4, 0, the location of the two x-intercepts, negative 5, 0, and 5, 0. We're asked to find the equation of the ellipse and the sketch. And to do that, we're going to start by just writing the standard equation for an ellipse. X minus the h coordinate of the center squared over the horizontal distance a squared plus y minus the k coordinate of the center squared over the vertical distance b squared equals 1. So if we can find all the parts h, k, a, b, and plug it in here, we'll have the answer to the question, the equation of the ellipse. Now, to start acquiring some of this information, the first step, step 1, is to start the sketch. And we don't have to do a beautiful job here. It's just the beginning to get information. Okay, so I drew the x-axis, the y-axis. I located the negative 5 and the positive 5 on the x-axis. Those are the x-intercepts. And they're not really information in themselves of what I need to plug into the equation. But I do know that since this ellipse has its focus, the foci are located at negative 4 and 4. So let's go ahead and draw those in. That's negative 4 and positive 4. So if we know that the focus always has to live on the major axis, so that's why I drew the upper and lower points from the center a shorter distance. I know the major axis has got to be the same axis that the focus live on, the foci, both of them. So let's label this. This is one of our f's. We'll call it f sub 1. It doesn't matter whether you call it f sub 1 or f sub 2, but just make them different. Okay, there are two foci. And we know since we're crossing the x-axis here and we're using the symmetry, there's no choice but for the outer points to be the location of the vertices, v sub 1 and v sub 2, because the foci and the vertices live on the same axis. Okay, so we could actually go ahead and start our sketch coming around here to the vertex and coming back around to this lower point. I don't know exactly how far down that is. And then coming out here to the vertex, coming around to the lower point. Okay, not a very good picture at all. It should be symmetric, and mine is terrible. I don't have graphing paper, so I'm not doing a very accurate job. Okay, so just have to use your imagination. Let's describe what the edges, label the distances on the edges. We know that the distance, we saw in our recent video, that the distance from the center to the top and the bottom is always going to be called b. So this distance is b on the top and at the bottom. We also know the distance from the center to either of the focus, that always is called c. So this distance is called our c. And that leaves only the distance from the center out to the vertex, that is the edge distance a, which also will be the distance from the top down to our focus. That has the same label A. That's a right triangle. And we can see from the symmetry of the picture, if I had drawn it correctly, that the center, HK, is located at the origin, 0, 0. And so we've got huge amounts of information here. We can see that the center HK, which is something we're looking for, is very important. So we're going to actually write down that the ordered pair HK is 0, 0. And we'll use that. It's important because we're going to plug it into this equation eventually. All we need to figure out is the distance A and the distance B. Now, we don't know B because we don't know how high and how low the distance is from the center. Do we know A? Well, you know that A is the distance from the center out to the vertex. And we've identified the vertex as a location because of the symmetry, the location where the ellipse crosses the x-axis. So that means that the distance A is equal to 5. Okay, because it's 5 units to the right and 5 units to the left of the center. All right, all we're missing now to plug into our equation is the value of the distance b, and we do not know what it is, but what we do have is a right triangle. Step 2, we're going to draw the embedded right triangle. We're going to bring it out. Right triangle. Okay, so it looks like this, this, and this. And let's label the edges of this right triangle. This, of course, is the center, HK, 0, 0. And this is the focus, F. And we have established that the distance on top is called A. So we know that that is A equals 5. And this is the distance B, which is what we're looking for. But we also have the distance C down below. And we know what that distance C is. Look at the picture that we drew in step 1. They gave us the location of the focus, and C is the distance from the focus to the edge. So in this picture, it's clear that the C distance is 4. So here we have a right triangle. We know 2 of the sides, and therefore we can use Pythagoras to get the missing side. Okay, so step 3, we're going to find side B using Pythagoras. Okay, so Pythagoras would say, for this particular picture, the hypotenuse squared would be A squared equals the leg squared plus leg squared, B squared plus C squared. Remember, hypotenuse is the edge that's across from the 90-degree angle. Okay, so what does that tell us for this picture? It says that 5 squared equals B squared plus 4 squared. All right, that means 25 equals B squared plus 16. Let's turn this around and isolate the B squared. B squared is equal to 25 minus 16. B squared is equal to, let's see, 9. So B will be equal to plus or minus 9, but don't keep the minus 1 because this is a distance. We're only working with positive here. So just keep the positive. B will be equal to 3. We don't really need to know that because B squared is what we need to put into our formula. So we're just about finished with this. Step 4. Substitute. H equals 0, K equals 0, that's our center. And let's see, A equals 5. We should say A squared. A squared equals 25 because we're going to substitute A squared in there. And B squared equals 9. So we're going to substitute all of that into x minus h squared over a squared plus y minus k squared over b squared equals 1. And that will give us our answer. It is x minus 0, so it's just x squared, over a squared is 25, plus y minus 0 squared is y squared over, is it 9, equals 1. So there's the equation of our ellipse. And the sketch was the other thing they asked for. We started the sketch. We could do another real quick version of it here. The sketch looks like this, like this. It goes up to 3, because that's B value, down to 3, that's negative 3. Then it goes out to the right to 5. It goes to the left to negative 5. I'll try to draw better this time. It has a focus at negative 4, another one at positive 4. Let's put these points together to draw